Okay, so we studied linear objects, we studied linearization of any object, and that means that studying all the curves that we made an attempt to study all of them, we first outline what it means to be linear. And then we say, okay, any other curve can be linearized. Well, in the sense that localized and linearized replaced by a linear curve. Is that true? Is it true that any curve at any point can be linearized? Because then calculus will study all the possible curves very successfully. It will be only calculus that you need to study all the curves. Can you linearize any curve at any point? And the answer is no, and that's why you need to study other things other than calculus. If you take a corner and you choose that point and you zoom in, and no matter how close you zoom in, the corner will remain a corner. That point will never, that piece of the curve will never look like a line for you. So there are curves out there that you cannot linearize. So there are linearizable, if there is such a word, curves. And there are other curves out there. And this is what calculus can study. This is what you can learn about curves using calculus. And I think for you, having calculus and considering calculus as a method, it's important to understand clearly the method itself, right? How you study things using calculus, and also to understand the limitation. What are those objects you should not even think about applying calculus to? So, for example, have you heard of fractals?
Yes.
Yes? No? Fractals? So, for example, if you look at a map and you want to study the shoreline of Great Britain, so you have Great Britain on a map, right? And of course there is shoreline, and it's usually very nicely shown there on a map. But then you take a different map that zooms in to a piece of that shoreline. Will that picture remain exactly the same on that finer map? No, it will show you more details. Right? And then if you take another map, zooming into that piece, will it remain the same piece as in the previous map? No, it will show you more details of how that shoreline is curved. And you can zoom in and zoom in and zoom in, and you will never get something linear. Well, unless you go into atomic structure of, but then you lose the concept of a shoreline, right? So in practice, in cartography, you are limited in studying curves, because now I'm talking about the curve, a simple closed curve, and if I want to study it, I better avoid using calculus, or at least I should be careful about applying calculus, because it probably doesn't apply or applies with some limitations. So I will mention from time to time limitations of calculus, but I will mostly focus on these two steps, on identifying linear objects and studying how things can be linearized and studied using calculus.